Hey, what's up? Welcome back, Patrick here, and moving on to the next question in the midterm review. So here we have a few statements, 5 statements, and we have to see which of these 5 statements here are going to be true and which ones are going to be false. So let's go through them one by one. So in part A, we're told that negative root negative 5 and the square root of negative 3 over root 4 and negative square root of 4, that these are all imaginary numbers. So if we go through these one by one, well, notice that this one, negative root 5, because we're square rooting, we're taking the even root of a negative 5, then we know that this one is going to be an imaginary number, right? Because we can't take the even root, we can't take like the square root or the 4th root or the 6th root of a negative number. Now, let's say that, for example, there was maybe a 3 here. Okay, then this wouldn't be an imaginary number because you can take the 3rd root of a negative. Okay, but here, square root of a negative number automatically makes it imaginary. Now, what about this one here? This one's a little bit more complex. So this one we can simplify to the square root of negative 3 over 2, right? That's square root of 4 there, ends up being a 2. And again, you're taking the square root of a negative number. Negative 3 over 2 is like negative 1.5. You can't take the square root of a negative number. So this one is going to be imaginary. And then this last one, almost, but notice that this is a positive 4, right? Even though we have a negative on the outside, we're taking the square root of a positive 4, which is just 2. So this is going to end up being a negative 2, which is a real number, right? It's not an imaginary number. So because of this last one here, this first statement is going to be false, right? These two were imaginary numbers. This last one here was a real number, which makes the statement false. Okay, part B. We're told that 0.27 repeating, right? This means that that pattern repeats, and 0.27% are equivalent to 3 over 11. Well, I mean, we didn't even have to see the 3 over 11. The fact that they're saying that this and this are equivalent, right? Because if both of them are equivalent to something, it means that they're both equivalent themselves, right? Well, these are not equivalent, right? 0.27 repeating, that decimal is just going to be 0.27, 27, 27 repeating like that forever, versus 0.27%. Okay, that one is going to end up being as a decimal. So like, for example, 1% as a decimal is 0.01. So that means 0.27%, right? If we divide this by 100, we will have 2 zeros there. That's going to end up being 0.0027, like that. That's what 0.27% as a decimal ends up being. And notice that these are totally different, right? So these are not equivalent to 3 over 11 because they're just not equivalent to each other. The 0.27, by the way, repeating this decimal is equal to 3 over 11, right? If you take 3 divided by 11 in your calculator, that's the decimal you would end up getting. But 0.27% is not equivalent to that. So that statement is false as well. Part C, so we're told that the 3rd root of 3 times the 3rd root of 9, the square root of 50 over 2, and the square root of 3 plus the square root of 9, that all 3 of those are rational numbers. So let's go through them. Notice that because we got the 3rd root of something times the 3rd root of something, it means that we can actually multiply what's under that 3rd root, right? So the rule is if you have the nth root of A times the nth root of B, you could combine those to be the nth root of AB, right? It's just these have to be the same. So if this was like the 3rd root of 3 times the square root of 9, then you can't combine those radicals. But because they're both the 3rd root, you can. And so you'd end up with the 3rd root of 27, and the 3rd root of 27 is 3. All right, so this ends up being 3, which is a rational number, right? Any integer is a rational number. Here you're going to have the square root of 50 over 2, which is the square root of 25, which is equal to 5. So that's also going to be a rational number. What about this last one? Well, this right here, this square root of 3, gives it away that it's not going to be a rational number, right? The square root of 9 is equal to 3. However, the square root of 3, that's going to give us a decimal with no pattern, or a decimal that doesn't terminate, right? And so whenever you take the square root of a number and it doesn't give you a decimal that either terminates or repeats a pattern, then you know that that number is going to be irrational. And then an irrational number plus a rational number of 3, that whole thing still ends up being irrational, right? So again, in this statement, it's that last expression there that made the statement false, and more specifically, it was that square root of 3, right? These two were rational numbers. This one here is an irrational number. Moving on to the next statement, so we got the third root of 27 plus the third root of 64 plus the third root of 64 plus 27 is going to give us the third root of 27 times 64. So let's go through these individually and see what happens. So the third root of 27, that's just simply going to be 3. The third root of 64, that's going to be 4. Now over here, this is going to end up being 91 under the third root. And the third root of 91, it doesn't give us a smooth integer value. So, or any fraction rather, it doesn't give us a rational number. So it's actually going to be an irrational number. It's going to be like 4.4 something. And it's just going to not have a pattern and continue on infinitely. So we'll just keep it as like the third root of 91 for now. And then on this right side, there's actually two ways you could do this. So you can multiply these two and then take the third root of that number. But you could also take each of them separately like that. And the third root of 27 is 3, third root of 64 is 4, 3 times 4 is 12, right? So this right side is going to simplify to 12, which is a rational number, versus this left side, it's going to simplify to 7 plus this irrational number, third root of 91, right? And so we know that these here, they are not equivalent, okay? So this statement here is going to be false. And then part E, we're told the absolute value of -4 minus the absolute value, it's like an absolute value right here, of -10 is greater than the absolute value of -4 minus 10. So let's just go through it and simplify this. So we'll have the absolute value -4 minus, now the absolute value of -10, that's just 10, right? So it's going to end up being like this. -4 minus the absolute value -10 is a positive 10, right? This ends up being a positive 10 like that. This negative is this negative right here. It's not this negative. That negative went away. This negative here ends up going here in front of the 10. So -4 minus 10 is -14. The absolute value of -14 gives us positive 14, right? So let's see what the right side is going to simplify to, and let's see if this statement ends up being true. So absolute value of -4, that's going to be positive 4, minus 10, right? Again, this minus is here. This minus went away because the absolute value of a negative gives us a positive. So 4 minus 10 is -6. Absolute value of -6 is positive 6. Is 14 greater than 6? Yes, it is. So this statement here is true. All right, so when you're getting a question like this, just go through each part of this statement very carefully and then see if there's any contradictions. And if there isn't, like there is in part E, that was our only true statement actually, then the statement is true. If you do find just one contradiction somewhere, the statement ends up being false. And that is the end of the video. Hopefully you enjoyed that. If you want to find more videos like this, you can go to my website, allthingsmathematics.com. Over there, all my courses are organized for both high school and university. All the videos are organized by chapter. Also, if you have any questions, you can hit me up. My contact details are also on the website. Enjoy your day, and I'll catch you in the next one. Peace out.